The 6000 series has an analog bandwidth of 350 megahertz, so it's possible to monitor signals up to this bandwidth. The particular signal applied at present is in fact an STM4 signal, which actually has a clock rate of 622 megahertz, so it would not be possible to measure the clock, but the data rate is half of that, 311 megahertz, so we could use this instrument to monitor that data. We couldn't truly characterize it because that would require an instrument of 3 times the bandwidth, so it needs, say, an instrument with a 1 gigahertz analog bandwidth, but we can monitor the signal. To achieve this, first thing we have to do is couple the signal into a 50 ohm terminator, and that is possible in the coupling menu. So now the signal is truly terminated, and now we can increase the time base rate, and we could actually look at the individual pulses and make some measurements on them. Further thing we could do is use the long memory to acquire a whole sequence of pulses and analyse them. So to achieve this, I'm going to provide a wider time window, in fact of 10 times the sweep rate, so it's 200 microseconds, and that the record length then selected is 1 million samples, and we are achieving that. We can see with the sample rate of 200 picoseconds we are acquiring 1 million samples. So again, we could stop the acquisition, and we could then use the zoom tool to zoom in and again look at the individual pulses in the sequence. So here we start to see the individual pulses. In fact, interesting, we can now see that it's apparently the pattern is repeating, so we could try and trigger on this low pulse and see if we can measure the sequence. So I'll just use the cursors to measure this negative pulse. So it seems like we have a pulse width of 10 nanoseconds. So I'm going to use one of the advanced trigger libraries to trigger on that. So I'm going to use the level dropout. So I'm going to be looking for that level to go down for 10 nanoseconds. And then do an auto trigger. And then we can see now we are triggering on this negative pulse. I'll just stop the action. So now we can see that yes, there is a repeating pattern, and again we could use the cursors to measure that. So if there's that low going pulse, and we can see at the trigger event that reoccurs. So this sequence occurs every 203 nanoseconds. So it is possible to use the instrument to monitor some of the characteristics of this data sequence. Another characteristic we could look at is the jitter on this particular sequence. So again we'll run the acquisition, and I'll put the trigger back to a simple edge trigger for this example. And then increase the remove the cursors, and I'll increase the sweep rate out. So yes, there could be some jitter there. In fact, I'm going to pass the signal through a network which does add some jitter, and now we could actually use the persistence mode to have a look at this particular jitter. So here's my trigger point, so I'll just move the trigger point to the left hand side of the screen, and now we can see we have some data dependent type jitter on this particular signal. So again we could use the cursors to now measure the data jitter on this particular signal. So here we see we're getting something like 430 picoseconds of jitter. What we must remember in this particular instrument, the sample rate is 200 picoseconds, so we're only getting points every 200 picoseconds. So 200 picoseconds is the uncertainty of the measurement, but if jitter is worse than that, we can monitor it and make some measurements.